Alright, ladies and gentlemen, in this lesson what we're going to be discussing today is a method for how you can solve a system of equations using matrices in a process known as triangularization. Now, uh, basically what you're going to have, pardon me, you're going to start off with some system of equations. I'm going to use an example of a system of three equations just so we can because that's primarily what we're going to be using it for. So let's say we have ax plus by plus cz to be equal to some constant number j. And then the second equation, we have dx plus ey plus fz to be equal to some number k. And then our third equation is going to be gx plus hy plus iz to be equal to some number L. So this is, say, a system that we're asked to solve. Now, this approach is going to be different than an algebraic approach where you would identify a particular variable that seemed the most likely to get rid of, and where we would kind of eliminate one variable twice so that we could simplify a system of three equations back down to a system of two equations, solve for the two variables in that system, and then go back and find the third one. Instead, what we're going to be doing is we're going to be creating some matrix based on the system, and we're going to use the matrix to identify what the solutions are going to be. Well, we're not exactly going to use the matrix to tell what the solutions are, but we're going to use the matrix to create a system that will allow us to find these solutions much easier than the system that we were starting with. So the augmented matrix that we would produce from this particular system that we have would be A, B, C, and J for the first row, D, E, F, K for the second row, and G, H, I, and L for the third row. So this would be the augmented matrix that my made-up system gives us. And what we're going to be doing is we're going to try and create something that we've seen in previous lessons where these three values here, the bottom three numbers, whatever those numbers happen to be, what we're trying to do is we're going to make sure that all of those numbers are zeros. So that's what you're kind of seeing in the text here where it says create a triangle of zeros below the diagonal entries. Well, in this case, the diagonal entries of the coefficient portion of the augmented matrix would be whatever A, E, and I are. So the numbers beneath the diagonals would be whatever D, G, and H happen to be. So that would be the augmented matrix that we would produce from the system, and our end result, what we're going to be striving for, is going to be an augmented matrix that looks like this, where A, B, C, and J in the first row are the same, but D has been replaced with a 0, E is still some number, F again is still some number, and K again still just some number. And then the G and the H are, the G and the H are now zeros. So that is what they're referring to, is we have a triangle of zeros in the numbers below the diagonal entries. So this is our final goal as far as a matrix is concerned. We're going to take whatever augmented matrix that we start with, do a few row operations on it, and produce an augmented matrix where all of the numbers underneath the diagonal entries are 0. Now we're going to do a couple, there's a certain way that we're going to be doing this. There's a very defined process that we're going to be doing here. And it's a little bit more structured than the algebraic approach to how we solved a system of three equations in the past. It's going to be fairly straightforward as far as you do this, this, and this every single time. Okay, so the very first thing that you need to do is write your system of equations as an augmented matrix. And we already just saw an example of that where I just kind of made up a system and created an augmented matrix. So the next thing it tells us to do, okay, we're going to use some row operations so we can get the zeros underneath the diagonal, or the numbers underneath the diagonal become zeros. So the first number that we're always going to be working with is always going to be whatever is in row 2, column 1. We have to do some row operation to make that become a 0. And after we do a row operation, we're going to have a new matrix that would kind of be like this, where this number here in row 2, column 1 is now a 0, and we still have numbers kind of everywhere else. Okay, so the very first thing that you're going to do after you've made an augmented matrix is you're going to say, okay, well, what row operation could I perform between the 3 rows where I can make whatever is in row 2, column 1 become a 0 after I do a row operation. So the very next thing that you're going to do is we're going to say, okay, whatever is in row 3, column 1, that now has to become the next thing that we focus on and say, okay, well, what are we going to get? So from the matrix that we did after we did our forced row operation, we're going to do another one. And after we're done doing that, we're going to wind up with a new matrix where now row 2, column 1 is a 0, and row 3, column 1 is also a 0, and everything else is, still some kind of a number. And the last thing that we're going to be doing as far as the matrices are concerned, now what we're going to do is we're going to say, okay, what do I have to do? We're going to do some new row operation so that will allow me to have row 3, column 2 become a 0, and my final augmented matrix is going to look something like this, obviously with numbers instead of just variables here. Okay, so that last matrix is going to be the final augmented matrix that we're really going to be working with, and it's produced by doing 3 different row operations where I do it in this order all the time. The very first thing I do with my matrix is I'm going to say, what do I do? What row operations could I produce that would give me a 0 in row 2, column 1? Then the very next thing you're going to do is say, okay, do the next, same operation. Okay, what am I going to do that will allow me to have row 3, column 1 produce a 0? And then finally our third row operation says, what can I do that would give me a 0 in the element of row 3, column 2? Okay, so those, you're gonna, that's where the structure comes from. You're always going to do those 3 things in that order. Row 2, column 1, row 3, column 1, and then row 3, column 2. Now, once you have your final augmented matrix, which if you don't necessarily have to write this down again because you probably have it somewhere in your notes, but let me just go ahead and write it one more time here. So we have A, B, C, J, we have a 0 here, E, F, K, and then a 0, I, and oops, I want to write a J again for some reason. Make that an L, keep things consistent. So this is our final augmented matrix. And from this matrix, what we're going to do is we're going to, so I called this matrix R. What we're going to do from here is turn it back into a system of equations. So the first row would give me an equation that would say ax plus by plus cz is equal to some number j. And if you notice, nothing at all ever changed in row 1. Everything was the same. Row 2 gives me a new equation that would say ey plus fz to be equal to whatever number k is. And then the final one is going to give me whatever I is times z to be equal to whatever number I have here. And so by doing those 3 specific row operations, we are able to have a matrix that produces a system of equations that is going to give us a lot less difficulty in solving. At this point, when I have my system, I'm going to take whatever this third equation is. This is actually the first thing I look at here. Oops. Trying to blend 2 words together. What we're going to do first here is just solve for z, whatever it happens to be. So here, the first thing I'm going to do is find z. And once I know what z is, I'm going to come to the middle equation, substitute that z value into the middle equation, and figure out whatever y is. And then once I know what y is, I'll take the 2 numbers that I know and come back to the first equation and find my x value. And that is how we're going to, produce this matrices with this process known as triangularization to produce an ordered triple as our solution. Okay? So that is the concept. That's the process that we're going to go through. Now let's take a look and see how we're actually going to do it with a real system. So the very first thing that you're going to do, no matter what, create very first thing we're going to do is create an augmented matrix. I'm going to call my augmented matrix B just because. The really only reason I'm picking B as the letter to represent the matrix is because there's a clear difference between the capital letter B and the lowercase letter b when we're referring to the matrix or an element. Okay, so the first row would give me 2, -1, 3, 14. My second row would give me a 1, 2, -1, and -3. And my third row would give me 4. Because the y is missing in the third equation, I have to place a 0 to represent the missing y value, and -2 and a +2. So here is our augmented matrix. Okay, now from the augmented matrix, the next thing that we're going to do is whatever is in row 2, column 1, we have to make it become 0. So that means this is where you have to identify, okay, row 2, column 1 is the value 1. And using the 2 above it and the 4 below it, we have to say, okay, what out of those 2 rows, row 1 or row 2, would it be easier to combine with the 1 to make it become 0? And in this case, I think we could use row 1 and row 2 easier than it would be to use row 2 and row 3, simply because the 2 and the 1 overall are smaller numbers. So a row operation that I'm going to do here in order to give myself a 0 in that position is I'm going to say I'm going to take row 1, and I'm not really going to do anything with it, but I'm going to take row 2 and I'm going to multiply it by a -2 and combine it with row 1. And when I do, whatever that new combination is becomes my new row 2. So let's go ahead and do that. Row 1, we're not going to do anything to it. We're going to just write it out so that way we have it. And now I'm going to take row 2 and multiply everything in there by a -2 and combine it with what I had in row 1. So a -2 times the 1 that's there is a -2. And you can see when we combine those, that will give me a 0, which is what I want. Negative 2 times a positive 2 in row 2, well, that's going to give me a negative 4. The negative 2 times the negative 1 will give me a positive 2 here, and the negative 2 times negative 3 in row 2 will give me a positive 6. And we're going to just combine these column to column. So the 2's in the far left column that produce a 0 when you combine them. Then we get a negative 5, a positive 5, and a 20. So this becomes my new row 2. So after we perform a row operation, you have to rewrite the matrix. So the next thing that we're going to do is to write the new matrix. Now, in the first row, we didn't do anything. Nothing changed. So we have 2, negative 1, 3, and 14. My row 2, my new row 2 is the 0, negative 5, positive 5, and 20. And row 3, we didn't change that at all, so that's still 4. Oh, somebody just came over the intercom and decided to try and scare me, I guess. Negative 2 and a positive 2 for my final row. So here is here's matrix B rewritten as with our new row 2. All right. Now the very next thing, according to the process that we were evaluating a little while ago, what we're going to look at now is, okay, the element that is in row 3, column 1, we have to make that become a 0. Now at this point, you want to make a note to yourselves. At this point, we can only use row 1 and row 3. In the first operation, we could have used any rows. We could use row 1 with row 2. We could have used row 3 with row 2. So that way we could have tried to get that 1 to become a 0. But in this case, we can only use the first and the third row. And the reason is because we've produced a 0 in that second row, first column. Uh-oh. People are having fun down in the office. They're making a whole bunch of noise. It shouldn't be happening. So pay no attention to the sound effects here. The reason why we can't use the second row anymore is because that 0 is there now. Because that 0 is there, there's nothing that can multiply to it that would actually allow me to have a negative 4 to cancel out the positive 4 that we need to get rid of. So this is why we can only use row 1 and row 3 here. So between the 4 that I need to get rid of and the 2 that's in the first row, we can say I'm going to take the first row, multiply it by a negative 2, combine it with row 3, and whatever I get, that becomes my new row 3. So let's go ahead and do the row operation. So I'm going to say multiply negative 2 to everything in row 1. So negative 2 times a positive 2 is going to give me a negative 4. Negative 2 times negative 1 gives me a positive 2. Negative 2 and a positive 3 gives me a negative 6. And negative 2 times a positive 14 will give me a negative 28. All right, and so row 3, we're not multiplying it by anything, so I'm going to say 4, 0, negative 2, and positive 2. So we're going to go ahead and combine those. And here's a 0, which I wanted. Here's a 2. Here is a negative 8. And here's a negative 26. So this becomes my new row 3. All right, so the next thing that we're going to do is, after we do a row operation, I'm going to write another matrix. So we're still looking at matrix B. So row 1 hasn't changed. In fact, row 1 never changes. So 2, negative 1, and uh, and I'm running out of room here. So what I'm going to do is I'm going to rewrite that matrix. I got a clean screen just for this purpose. So I'm going to rewrite this matrix on my next screen. So here we're at. Here's what we're doing. I'm going to write the new matrix. So we're talking about matrix B. So row 1 is going to be my 2, -1, 3, and 14. Oh my God, with the sound effects this morning. Row 2 is still the 0, -5, +5, and 20 that we came up with earlier. And row 3 is now going to be 0, 2, -8, and -26. So here is my latest iteration of the matrix. And so now what we're going to do is we have one more row operation. We have to say, okay, the element of row 3, column 2, now has to become 0. And so we're going to ask ourselves, all right, well, last thing we have to look at, what am I going to do to make the 2 that's in row 3 become a 0? Now at this point, again, you might want to make a note to yourselves. At this point, we really only want to use row 2 and row 3 because if I try to use row 1 and eliminate the 2 that is in row 3, when we combine the two rows together, the 0 that we just found for row 3 will go away. So that's why we only want to use row 2 and row 3 at this point. So the row operations that we're going to be looking at is going to be determined with the -5 and the 2. So the smallest number between the -5 and the +2 is a 10. So I'm going to take row 2, multiply that by 2, take row 3, multiply that by 5, and whatever that is, that will give me my new row 3. So multiply the 2 to everything in row 2, and that'll give me a 0, a -10, a +10, and a 40. And then multiply 5 into everything in row 3, and that'll give me a 0, a +10, a -40, and 5 times 26 is going to give me, in this case, a -130. So combine all of this, and I'm going to get 0, 0, which we needed. 10 minus 40 is -30, and 40 minus 130 is -90. So this is now my new row 3. So this is going to produce my final matrix. So all these letters are blending together here. So let's see. Write my final matrix. And my final matrix is going to be 2, -1, 3, 14. Row 2 is still 0, -5, 5, and 20. And row 3 is now 0, 0, -30, and -90. And this is our final matrix because in the lower left corner, the values that are underneath the diagonal are nothing but zeros. So we've now created a matrix of zeros. So next, I'm going to write my new system from my final matrix, and then I'm going to be able to solve for x, y, and z. So my, excuse me, in my equation, my first row is going to be 2x minus y plus 3z to be equal to 14. And now I'm going to have negative 5y plus 5z to be equal to 20. And then finally, negative 30z to be equal to negative 90. So again, we're going to solve for z first. And the way I'm going to find z is just divide both sides by the negative 30. So negative 90 divided by negative 30 is 3. So we have that. Now I'm going to take that and stick it into that second equation. Find out what y is. So I'll just kind of use this space underneath here, and I'll say negative 5y plus 5 times 3. So that'll give me negative 5y plus 15 to be equal to 20. So that means negative 5y is equal to 5. So that means y is equal to a negative 1. And now I'll take the z and the y that I know and find x. So I'll use the space here to the right to find x. So that'll be 2x minus a negative 1 plus 3 times 3 to be equal to 14. So now let's go ahead and solve this guy out. So that'll give me 2x plus 1 plus 3. So that gives me 2x plus 4 to be equal to 14. So that means 2x is equal to 10. So x oops, I think I made a mistake here somewhere. Yes, I did. I'm not paying attention to my arithmetic. 3 times 3 is not 3, it is 9. So 3 times 3 here is 9, so 9 plus 1 is 10, so move the 10 over to subtraction, that's a 4. There we go. So x is 2. So my final solution, written as an ordered triple in XYZ order, will be 2, negative 1, and 3. Okay? Now, really, some of us are going to say, well, Mr. Pierce, that's a lot of work. Well, it's not really any more work than what we were doing, but the advantage that I think some students are going to see with this is that because it follows the same structure each and every time for every problem, there's less opportunity to make a mistake process-wise. There still is an opportunity to make a mistake, by missing a sign or multiplying something wrong or, something basic. But process-wise, which is primarily what I'm kind of looking at, we need to make sure that we're doing that okay. So now, final thing here, the last example, I'm going to go through this one a little bit quicker. So first thing I'm going to do is create my augmented matrix, and I'm going to go ahead and call this one matrix H. Again, really because there's just a difference between the capital and the lowercase letters. So we're going to get 1, 1, negative 2, negative 1 here for the first row, 4, negative 1, 3, and 3 for the second row, and 3, 2, negative 1, and 4 for the third row. All right, so now the next thing that we're going to look at is we want to make whatever is in row 2, column 1, we want to make that become 0. So looking at the 1, the 4, and the 3 that are in column 1, I think I want to make that 4 become a 0. I think it'll be better to use the 1 and the 4 because that'll give me less work to do. So I'm going to take row 1 and multiply it by a negative 4, combine it with row 2, and whatever I get here, I'm going to put it in row 2. So let's go ahead and do our operation. So multiply negative 4 by everything in row 1, and I'll get a negative 4, a negative 4. Oop, I don't want them so close. Negative 4, negative 4, positive 8, and a positive 4. And row 2 is just 4, negative 1, 3, and 3. Go ahead and combine those. And there's the 0 that I wanted. Here's a negative 5, here's an 11, and here's a 7. So this is my new row 3. All right. So write my new matrix out. So we're still talking about matrix H. Row 1 didn't change, so it's still 1, 1, negative 2, negative 1. And row 2 is now 0, negative 5, 11, and 7. And row 3 is still 3, 2, negative 1, and 4. So next, we're going to make whatever is in row 3, column 1, become a 0. And again, at this point, we're only going to look at row 1 and row 3, because there's nothing I can multiply a 0 by that would make a negative 3 to cancel out the positive 3 that we're trying to get rid of. So that means I'm going to take row 1, multiply it by a negative 3, combine it with row 2, I'm sorry, not row 2, row 3. And that will give me my new row 3. Oops, and I put row 2 here. That should be row 2. All right, so multiply. So negative 3 times 1 will give me negative 3, negative 3, positive 6, and positive 3. And then I'm going to have the positive 3, 2, negative 1, and 4 from row 3. Combine your columns. Here I get a negative 1, positive 5, and a 7. So this is my row 3 now. So now I'm going to write my new matrix again. So we're still talking about matrix H. And so row 1 is 1, 1, negative 2, negative 1. And row 2 is my 0, negative 5, 11, and 7. Row 3 is now my 0, negative 1, 5, and 7. And now I'm going to say, what do I have to do to make row 3, column 2 become 0? Well, row 3, column 2, and at this point, again, we're only going to look at row 2 and 3. So between the negative 5 and the negative 1, we can multiply the negative 1 by a positive 5. So I'm going to, that will give me something that will cancel. So I'm going to say, take row 2 and then multiply negative 5 to row 3 and combine them, and that'll give me my new row 3. So we're not going to do anything to row 2, so we have 0, negative 5, 11, and 7. And then row 3, multiply everything in there by a negative 5, and I'll get a 0, positive 5, negative 25, and negative 35. So combine everything, and we get a 0, my second 0 for the third row, which we wanted. The 11 minus 25 is negative 14, and 7 minus 35 is a negative 28. So this is my new row 3. So let me go to a clean screen here. And so my final matrix here my final matrix, row 1 never changed, so that's still 1, 1, -2, and -1. My row 2 wound up to be 0, -5, 11, and 7. My row 3, final row 3, was 0, 0, -14, and -28. So here's my final augmented matrix, and from that, that's going to give me my new system, where the first row produces an equation of x plus y minus 2z to be equal to -1. My second row produces an equation that says -5y plus 11z is equal to 7. And then my third row produces an equation that says -14z is equal to -28. And again, I'm going to start at the bottom, find z, and just divide both sides by -14, and z is going to be 2. I'm going to take that and stick it into the second equation, and now I'm going to find y. So -5y plus 11 times 2 equals 7. So that work it out, and I'm going to get -5y plus 22 equals 7. Move the 22 over through subtraction, and I will get -5y to be equal to a -15. Divide by the -5, and I get y to be 3. So I'm going to take this and stick both of those numbers into the first equation, and now I'm going to find x. So next, so that's going to give me x plus a 3 minus a 2 times a 2 to be equal to a -1. So that'll give me x, -2 times +2 is a -4. And combine the like terms on the left side, so x minus 1 equals -1. Move the 1 over through addition, and in this case, x is 0. So my final solution as an ordered triple will be 0, 3, and 2. So again, the idea of the matrices that we're working with here is to go through a process known as triangularization, where the lower 3 numbers, or basically anything that's underneath the diagonal entries, we're going to make those a 0 using some row operation. Seems like it's a lot of work simply because you have to rewrite the matrix after every row operation, but it's really not that much work, not much more than what we were doing algebraically to solve a system of 3 equations. And there's a lot more structure in place, I think. So I think it'll be more helpful for some students using that structure, because you always do the same thing over and over and over again. There's still an opportunity for minor miscalculations with multiplying something wrong or forgetting a sign somewhere, but it's not the end of the world. We're still, again, kind of focused on how you can do the process. So please make a note of any questions or thoughts that you had that you want to address to me either in class or in tutoring. And thanks for watching, guys, and we'll see you soon.